Hi everyone, welcome to my channel. So I'm going to discuss the topic for week 6 and week 7, level on-off control system. So this topic is for automation 1. So we have here various automatic controls introduction. So on-off control, sequence control, proportional, integral, derivative, or PID control. Learning objective: describe briefly on-off control, sequential control, and PID control system. So, learning objective number 8, explain how on-off control, sequential control, and PID control systems are being utilized for a typical ship's main engine system. So, on-off control, sequential control, and PID control means taking some applications as examples. So characteristics of on-off control, sequential control, and PID control, and how they are being utilized. Components comprising on-off control system, sequential control system, and PID control system. So after the discussion, we'll conduct oral recitation, give quiz 5. So in this, you have also exercises 6 and 7. So 6 is level on-off control and 7 is on-off level on-off control system, and 7 is sequential control system. So I already uploaded these exercises in your binocle. So first, you have here the on-off control is the simplest form of feedback control. An on-off controller simply drives the manipulated variable from fully closed to fully open depending on the position of the controlled variable relative to the set point. A common example of on-off control is the temperature control in a domestic heating system. But here our example is this is air condition system, and this is a refrigeration system. So how it works, the on-off control. So we have here the cold control. So we have the what we call the contact here. So switching contact. So we have here the compressor and the fan motor, the defrost timer, and the thermostat. So we have the defrost timer, and it is plugged to the power source. So when the thermostat detects the more than the set value of thermostat, it closes here the contacts circuit, and if it is arrive in the set point, let's say for the metrum, it is minus 18 degrees Celsius. So it is automatically open the contact circuit. So the works of these contacts is only to on and off. So that is an example of on-off control system. Next, we have also here the on-off control system scheme. Uses here the water level of tank. So we have the set point, and we have the level switch to start. So start level switch, L1 and start level switch L2. So we have the flow here, inlet and the outlet of the bulb, solenoid bulb, electrically operated. So this is connected to the power supply, and P1 closes at L1 and P1 opens at L2. So when this level is here below the level here in the L1, it closes the circuit because of the float here. So it is not shown here the float, but so it depends on the type of sensor. It is if it is the float type or the other type of sensor. So when the float here is going down because of the lower level of the water, so it closes the circuit, and the flow of the electricity will flow because of the close contact, the closed circuit, and this solenoid opens. So close here, the circuit. This solenoid opens and give water to the tank. Fill water to the tank, and it also stop here. So which is off, here is on when the level is in the L2, and it detects the flow going up and open the circuit of the L2, and then this electrically operated solenoid bulb will be switching off. So that is L2 here is off and L1 is on. So that is one explanation of the on-off control. Next. So this one, this is a sequential control. So I will just give you this link in Binacle so that you can read also this one as part of the discussion of the sequential control. So instead of I will be discussing the sequential control, because I watched this discussion. This is explaining very well in the system, the sequential control system. So I will give you in the Binacle this link as part of our discussion. PID control system. So control system. So the basic idea behind the PID control system is to read a sensor. So then compute the desired actuator output by calculating proportional, integral, and derivative responses. So that is why that is called PID. Proportional, integral, and derivative responses, and summing those three components to compute the output. So where are the PID controllers used? Proportional, integral, derivative. PID controllers are used in the most automatic process control applications in industry today to regulate flow, temperature, pressure, level, and many other industrial processes variables. So let us come here in the illustration sample. So one of the application of the PID controller is the onboard ship cooling system of the main engine and the auxiliary engine, as well as the cooling system of the auxiliaries. So here we have high temperature controller, a high temperature press water controller, and low temperature press water controller. So in high temperature press water controller, as you can see here in this diagram, there is a line, this is a wire, is connected to the controller, this one. This is your PID controller. So when I click this one will come out, this window, for the high temperature press water PID controller. So as you notice here, there is a wire and there is a sensor here. So you cannot see the sensor because this is just a schematic diagram. But this is understood that there is a sensor in here. So these sensors sense a temperature and sends a signal to the PID controller. So it reads the signals. So since this controller is working in automatic, so there is no need human intervention or human interaction to control the set point temperature of this cooling water, high temperature press cooling water to the main engine. So this is for the inlet here. So the other PID is mounted on the low temperature press water cooling. So it's the same principle. It's just the setting of temperature here is lower temperature than the high temperature press water. So this is one example of the application of your PID controller used in the cooling water of the main engine and the auxiliary engine on board the ship. So let's say we will set here the inlet temperature of the high temperature press water of the main engine is 65 or between 65 to 70 degrees Celsius. So it maintains the temperature here at the inlet up to 65 or 70 degrees Celsius. So the same as here in the low temperature press water, if you put the set point here of 35 degrees Celsius, so it maintains the temperature of the press water in this circuit into 35 degrees Celsius because this is set into automatic. So these are application of the PID control. So not limited of the system, but this is used also the other system. So a wide application of the system for the automation. Next, so we have here in the characteristics of on-off control. So on-off controller, or here we have two position controller. So in this diagram, we have here the set point, the controlled variable, and we have the desired value here, and we have the timer here, and we have the switch, the on and off, so position of the controller. So here you have the time. So this is the diagram of the characteristics of the on-off control system. So talking about the characteristics of the sequential control, we have a comparison here of combinational circuits, which is combinational circuits are defined as the time independent circuits which do not depend upon previous inputs to generate any output are termed as combination circuits. So as you can see here in this circuit. So just like an open loop control system. So inputs, you have the inputs and you have the outputs. So here, sequential circuit. So I conclude this one. This conventional circuit is this is similar to the open loop circuit because you cannot see any feedback signal here. So here, sequential circuit. Sequential circuits are those which are dependent on clock cycles, and depends on present as well as past inputs to generate any output. So as you can see here, the external inputs, you have external inputs and you have external outputs. So this is still here a combinational circuit, but since this system is sequential circuit, so it adds here a memory element. So the add memory element. So we have the current state and we have the next state, and we have the internal output and the uh, internal input. So there is a memory element added. So if there is no memory element added, that is combinational circuit. And if there is memory element added, this is already sequential circuit. So uh, that is one characteristics of sequential circuit. Next, so this is the same on the uh, previous slide. So combinational circuits and sequential circuit. So remember, we will repeat. So under combinational circuit, the output depends only upon the present input, and there is no need for feedback for input and output. So memory element is not required. So I concluded this one. This is open loop control system, and the sequential circuit is, so the output depends upon both present input and present state, previous output. So memory element is required to save the feedback state. So this is a closed loop control system. So we have also here the characteristics of the PID controller. So proportional integral derivative PID controller. PID controller involves all the three controllers studied earlier. So PD and PI connected in parallel. So PID controller involves the parallel combination of three controllers, and the output equation is proportional to the derivative as well as the integral of the error signal. So this is the equation, and this is the diagram. So we'll continue. Proportional control KP will have the effect of reducing the rise time and will reduce but never eliminate the steady state of the error. So here, this one. An integral control will have the effect of eliminating the steady state error, but it may make the transient response worse. Here, PI. A derivative control, TD, will have the effect of increasing the stability of the system, reducing the overshoot, and improving the transient response. So all design of the specification can be reached with the PID controller, and desired conditions can be achieved. So here we have the characteristics of P, I, and D controllers. So in the proportional controller, we have here the reset time decrease and the overshoot is uh, increase. The sitting time is small change, and the sensor error decrease. So for the integral control, so reset times decrease, overshoot increase, sitting time increase, and error sensor eliminate. So ED, which is derivative control, so reset time small change, overshoot decrease, uh, settling time decrease, and sensor error is small change. So those are the characteristics of the PID controllers. So let us come to the list of components comprising on-off control system, sequencing control system, and PID system. So a feedback control system consists of the 5 basic components. This is the input, so process being controlled, output, sensing elements, sensor, and the controller, and the actuating devices. So here we have the diagram for that. As you can see, this is a closed loop control system. So you have the manipulated variable, control element, input, process, output, and you have the measuring element and the feedback signal to the control element. You have also the variable amplitude, control variable, and the operator control signal, and you have the controller, and send back the signal to the control element. It's the control signal, and here is your set point. So this is the uh, uh, list of components of the feedback control system. So in your activity, you have the continuous process control can be categorized into elementary on-off action and continuous control action. On-off action is used in applications where the system has high inertia, which prevents the system from rapid cycling. So this type of control only has 2 states, on-off. So hence its name. This type of control has been used for many decades, long before the introduction of the computer. So HVAC, this is air conditioning and refrigeration. So it's a prime example of this type of application, such as application do not require accurate instrumentation. So in HVAC, the temperature measured variable is continuously monitored, typically using a bimetallic strip. So your what we call your thermostat. So in older system and semiconductor elements and newer systems. So as the sensor turns the power manipulated variable on off at preset temperature levels to heating cooling section. So this is in your lab manual exercises. So just follow the instruction there. So we have here the closed loop system. So I already discussed this one a while ago. So remember the keyword of the closed loop system is a feedback control system. So this is your lab manual exercises. Exercise I already uploaded in your Binacle, in your LMS. So introduction to process control by Engineer Wira. So you can follow this link. You can follow this link in your lab manual exercises. So this is the end of the discussion. Please click like and share. Write a comment below, and then hit the subscribe button, and then click the notification button. Thank you for watching, and see you on my next video.